Hello everyone. Now having discussed about the classification of data, we now understand how the data is distributed. Now first coming to a very important distribution, which is normal distribution. It is a bell shape. It is in the form of bell shaped curve. Now if I place my hand here, the shape of this distribution looks like a bell. Secondly, this distribution is symmetrical. Suppose if I place a plane mirror here, the right hand side will exactly resemble the left hand side. So both the sides, if I divide the data into two parts, both the sides are mirror image of each other, which are exactly symmetrical to each other. Now, third important point is that it has other names, which are Gaussian distribution and de Moivre distribution. Now, I have pronounced this name as this because he was a French mathematician. Now, for remembering, you should remember it as de Moivre, so that you remember the spelling of his name. Now, area under the normal distribution curve is 1. The standard deviation of the curve is also 1. And the mean, median and mode all coincide at the center of the curve and all are equal to each other. Mean equal to median equal to mode in normal distribution curve. Another important concept is if you have a normally distributed data, then 68% of the value will lie between mean plus minus 1 standard deviation. The plus indicates the upper limit of the value and the minus indicates the lower limit of the 68% observation, where 34% observation will be on the positive side and 34% observation will be on the negative side, making it 68%. Now, similarly, 95% data will be covered by mean plus 2 standard deviation and 99% of the observation in normally distributed data will be covered by mean plus 3 standard deviation. Now, coming to the last point, which is very important point, that in normally distributed data, the test of significance which you are going to apply is parametric test. The examples of normally distributed data are the height, weight, blood pressure, or the exam score we get, where there is a peak and the number of observations are spread around the peak. And one more important thing you have to remember is that I have made the tail in a pointed direction, which means the data is extending infinitely on the positive side, and on the side also I have made a tail, which signifies that the data is also extending infinitely to the negative side. So the tail never touches the X line. It goes like this, continuous to the infinite values. Thank you.